All right, let's start talking about notes 9 here. We're going to be adding and subtracting radical expressions. So a couple of things up at the top. All right, so when you are adding or subtracting radicals, the number underneath the radical has to be the same to combine. So I like to think of this like terms. Okay, so when you have like terms for polynomials, you can combine things like 3x plus 4x because both of these terms have x's in them. However, you cannot combine 3x plus 4y. Okay, so when I think about radicals, if I take the x's out of this problem and instead, let's say I put a root 2 here and a root 2 here, these roots match. So those are like terms. I can combine them. However, all right, second problem here, if I take out the x and the y, and I replace, let's say, and I make this a root 2, but that a root 5, root 2 plus root 5, I can't do that. So these are not allowed to be combined. This would just stay as is. These two, I would be able to combine, and I would add just the coefficients. So 3 plus 4 makes 7, and leave the root 2 as a root 2. Again, kind of like if you had x's there, you would just have 7x. Okay, so the second one, right? So when the numbers underneath the radical are the same, add or subtract the numbers in front. Those are the coefficients. Okay, the number underneath the radical stays the same. Okay, I'm actually going to, well, I'll leave the highlighting bits. It's fine. So that's all there. And then if the numbers underneath the radical are not the same, we're going to try to break it down. Okay, so we're going to try to simplify those radicals, then combine the ones that you can. Okay, so we're going to do problem number 1 here, all the bits, parts, and pieces, because there's 4 little parts here. All right, some of them are going to be a little bit quicker because the radicals are broken or simplified. Some of them not so much. So part A here, if I look at my radicals, I have a root 5 and a root 5. I can absolutely combine that. So my answer is going to have a root 5 in it. What I need to do, though, is add the 3 plus the 8. So 3 plus 8 makes 11. And that is 11 root 5. Part A is done. That's it. Nothing else. I cannot break up a root 5. Okay, so sliding over to part B here. So this one, not like it's more tricky, just got more parts to it. So let's say I've got a root 2 here, root 3, root 3. Okay, there's another root 2. Oh, wait a minute. But this root 2, the number in front is blank. That doesn't mean there's a 0. That means we were lazy and we just never wrote the 1. Okay, so root 2, we got that. We've got a 3 here and a plus 1 here, so 3 plus 1 makes 4 root 2. And then separately, I've got a root 3 and a root 3. So those I can combine. So there's my root 3. And if I look at the numbers in front, I have a negative 5. Yes, the sign here goes with the 5. All right, so negative 5 and a negative 4. So that's going to get me a negative 9 or minus 9. So combining up all the terms here that I can, I get 4 root 2 minus 9 root 3. And at this point, I am done. A root 2 and a root 3 cannot be combined by subtraction in this case. Okay. All right, so part B is done. Let's slide on down here to part C. And this is where, okay, we've got a root 48, a root 27, a root 3, and a root, they don't match. Okay, none of those match. So what we need to do is see if we can break up any of these roots. All right, see if we can simplify any of them. So for this one in part C, I am going to do perfect squares. Okay, we've talked about breaking up roots in the past, and I'm going to simply use my perfect squares to do so. So the 5 stays that. 48 is the perfect square of 16 times 3. All right, 27 is the perfect square of 9 times 3. 6, root 3 is going to stay a root 3. I can't break it up. It's just done. Okay, so minus 2, and then root 12 is the perfect square of 4 times 3. Okay, so 5 here is that 5. Now, remember I said, as I was saying this, it was the perfect square of 16. Well, the square root of 16 is simply 4, and then we're going to leave the root 3. And I'm going to keep working my way across the problem, simplifying as I go. So let's see, the square root of 9 here, square root of 9 is 3. Then we'll leave the root 3. 6 root 3 isn't going to change. Minus 2. That was all just part of the original here. So I got the square root of 4. Well, that's 2 times root 3. So at this point, the good news is all of these terms actually broke down to root 3s. I'm not going to say bad news, but I still need to do some more math before I can even do any kind of addition or subtraction. So right here and right here, I'm going to do a little multiplication first. So we're going to have 20 root 3 minus 3 root 3 plus 6 root 3 minus 4 root 3. And now all of these are like radicals. So I'm simply going to work my way from left to right, adding and subtracting as I go. I know my answer is absolutely going to have a root 3 in it, okay? But let's see, I've got 20 minus 3 is 17. 17 plus 6 is 23. We'll go with that. And then 23 minus 4. I'm hoping the brain is mathing and I'm going to get a 19. So 19 root 3 there. All right, so that was using our perfect squares to break up radicals. If using perfect squares is not your cup of tea, then for part D, where I also root 8, root 32, and root 50, got to break them up, okay? With this one, I am going to use my factor trees, okay? So let's break up an 8. Any numbers that multiply to 8, let's go with 2 and 4. 2 is a prime number, so I'm going to go ahead and circle that one. That's a dead end. And then 4 is 2 and 2. So if you want to circle them so you know that your dead ends are done. And it's also kind of a nice way to keep track of you've actually used all your values. Okay, so we've got 3 here, and then for root 8, 2, 2, and 2. Okay, then minus, all right, let's see if I can fit the 32. So 32, what breaks that up? Let's see, how about a 4 and an 8? Neither of those are prime. 2 and 2. All right, so there's a dead end, there's a dead end. 8, 2 and 4. 2 is a dead end, and 4, 2 and 2. That's a lot of 2s. And I also realize I am not going to have enough space, so I'm going to go ahead and slide that on down. I write too large. Shocking. All right, so minus 2. And then under the root, I have 1, 2, 3, 4, 5 2s. So 2, 2, 2, 2, and 2. There's all my 2s. And if you want to put little multiplication dots in there, that's fine. I know that is not the number, 22,000, whatever. Okay. Then plus 4, and now I got to break up a 50 here. All right, so what multiplies to 50? How about 5 times 10? Okay, so 5 is a dead end. 10 is, how about 2 times 5? 2 is prime, 5 is prime, so there's my dead ends. And let's see. So underneath the radical, I've got 2, 5, and 5. The order that you write the numbers down doesn't really matter, but because I know what's coming next, I do like to write them in numeric order so that, yes, I have the 2 here and then the 5s there. All right, now what is coming next here? Well, what's coming next is I'm going to be looking underneath the roots, underneath the square roots, to see if I have any pairs of numbers. So I have a pair of 2. I meant to grab a pen. Let's do that again. I have a pair of 2s right here. Okay, so how does that simplify? Well, 3 stays out front times you had a pair of 2s. A pair of 2s. So 1, 2 comes out front, and then the thing that didn't pair up stays underneath. Okay, minus 2. Now I've got a pair of 2s and another pair of 2s. So this, you can do it this one of 2 ways. You can either write down times 2, whoa, hold on a second, times 2 times 2. This 2 here, the pair of 2s becomes the single 2 here. The pair of 2s becomes the single 2 here. And actually, you know what, I'm just going to let that be. I will write that the way that is. And then what didn't pair up, right, stays under the radical. And then plus 4, all right, I have a pair of 5s here. So we're going to take a 5 out and then leave the root 2 behind. I write huge. So let's go ahead and slide that up. So what happens next? Well, we got to multiply. 3 times 2 makes 6 root 2 minus 2 times 2 is 4 times another 2. That's going to be 8 root 2. And then plus 20 root 2. So let's see if we work our way from... Oh, by the way, root 2, and root 2, they're all like, so absolutely we can combine them. So left to right across, I'm going to grab 6 here, minus 8. So 6 minus 8 is negative 2. And then negative 2 plus 20 is going to get me a grand total of 18 root 2. Okay, so these problems are a combination of simplifying radicals and then combining, again, I keep referring to as like terms, but any terms that have the same radical, so root 2's go with root 2's, root 5's with root 5's, so forth, so on, those can be combined simply by adding up their coefficients. All right, that's going to be the end of this video. Send me any questions or concerns you've got, and we'll see you in the next one.